Hi everyone, welcome to 4.3, which is quadratic functions and their properties. So we've been talking about linear functions, and they were in the form of ax plus b. Typically we would use mx plus b. Remember that m was the slope and b is the y-intercept. We're going to move on to quadratic functions where the function is in the form of ax squared plus bx plus c. And we know that the graph of a parabola is or the graph of a quadratic function is a parabola. Okay, so some properties of parabolas, if we go to Desmos, and let me make this a slider. So as you can see, as a is increasing, the parabola is vertically stretched and becomes narrower. And as a is decreasing between 0 and 1, it becomes wider and it is vertically shrunk or compressed. A also controls whether the parabola is concave up, which is what this one is. And the vertex there, that middle point down at the bottom, is a minimum. It's down in a valley. If I was to make A negative now, as you can see, it reflects over the x-axis, and now it's concave down, and the vertex is a maximum because it's at the top of the hill. One way to find the vertex, either whether it's a minimum or a maximum, when you have your equation in standard form, ax squared plus bx plus c, I can use the formula to find x, negative b over 2a. And if I want to find the y value of the vertex, I would just plug in what I found for x into my function for x, and that would leave me with my y value. You also have an imaginary line going through the parabola. It's called the axis of symmetry, and it would just be if you were to fold the parabola in half, that the both sides would match up with each other. Okay, and that line is going to be vertical, and it's going to pass through the x value of your vertex. So as you can see, both of those values will be the same. The axis of symmetry is always going to be an equation. So you should always start it off with x equals. So let's take a look at this first equation, which is f of x equals negative 3x squared plus 6x plus 1. And without graphing, we want to locate the vertex and the axis of symmetry, and does it open up or down? So if you remember, the a value determines if it's up or down. And a here is negative 3, b is 6, and c is 1. And since a is less than 0, it's negative, our graph is going to be concave down. Okay, an easy way to remember it, if you spell the word down like this, okay, that's concave down. The vertex will be up here as a maximum. Okay, so how do I find the vertex? All I need to do is just take my formula, negative b over 2a. So b here is 6, and a is negative 3. And I get negative 6 divided by negative 6, which is 1. Now I'm going to take the 1 and I'm going to plug it into the function. So I'm going to find f of 1. And when you do that, 1 squared gives you 1. 1 times negative 3 is negative 3, plus 6, plus 1, and that is 4. So that tells me that my vertex is the point 1, 4. And my axis of symmetry, which I'm going to label as AOS, is just whatever your x value of your vertex is, that's the axis of symmetry equation. So it's x equals 1. So now if I want to graph that, 1, 4 is right here, and I'm going to have a again, vertical line going through the vertex. Okay, we also need some intercepts here. So we know already that the vertex is 1, 4, and that the axis of symmetry is x equals 1. But what about some intercepts? The easiest intercept to find is the y-intercept, right? So it's where x would be 0. If I go to my function and I fill in zeros everywhere there's an x, it's going to cancel out the negative 3x squared and the 6x, because 0 times anything is 0. All you're left with is the c value. So something important about c, which I'm going to add here, is that c is always your y-intercept. So here, the c value is 1. So 1 is my y-intercept, or 0, 1. Okay, so I'm going to put a dot on 0, 1. And what I need to do is reflect that point off the line. So if you were to fold across that line, you would end up with your other point right here. Same distance away, but on the other side. Okay, now I need to find the x-intercepts. So remember, the x-intercept is where y equals 0. Okay, and I need some more work for the, or some room for this. So to find the x-intercept, I need to do a couple things. So let me add a page here. Okay, so let's start out with the equation, which would be f of x equals negative 3x squared plus 6x plus 1. So to find the x-intercept, you would basically be making f of x 0. You have a couple options here. You could factor this. Not a good idea. It won't factor nicely. Or you could try using the quadratic formula. Okay, so if you remember, the quadratic formula, as long as your equation is in the form ax squared plus bx plus c, it allows you to use the formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Before you even go and use that though, I want you to focus on this inner part here. That has a name. It's called the discriminant. And the discriminant, it kind of goes unnoticed a lot, but it's really important. The discriminant tells you whether it's worth it to find the intercepts, because sometimes there aren't going to be any. So there's 3 cases. The discriminant can be positive, so greater than 0, and that just tells you there's going to be 2 real solutions. That means like when you graph it, the parabola is actually going to go through the x-axis in 2 spots. You could have the discriminant equal 0. That means there's only going to be 1 real solution. So that would look like a parabola where just the vertex is intercepting the x-axis. You could also have the discriminant be less than 0, where it would be negative. And if you'll recall, you can't have negative numbers under a radical. You can't take the square root of a negative number. So here there's no real solutions. They would be imaginary, and what you would get would be like a levitating parabola. So notice it's not going through the x-axis at all. So then that's telling you don't even bother finding the intercepts, because there are none. So you only want to focus on these 2, okay? If you get a discriminant that's positive or one that's equal to 0. So if I find the discriminant here, my b value is 6, and my a value is negative 3, my c value is 1. So that gives me 36 plus 12, which is 48. 48 is bigger than 0. So that tells me there's 2 real solutions. That tells me there's 2 x-intercepts. So I'm going to use the quadratic formula now and finish this off. So it's negative b plus or minus the square root of the discriminant that you just found all over 2 times a. So here I would get negative 6 plus or minus the square root of 48 over negative 6. Now, you can simplify that, and in case MyLab asks you to simplify to simplest radical form, I'll post a couple videos that kind of lead you through that. But we're just going to convert to a decimal here. So there's two answers, right? One of them is -6 minus the square root of 48 over -6. The other is -6 plus the square root of 48 over -6. So all I'm going to do is I'm going to type them into Desmos, and let's see what we come up with. So we're going to have parentheses, -6 minus the square root of 48, okay? And then I'm going to divide all of that by -6. So one of my x-intercepts is 2.15. For my other one, I'm going to do the same thing, except I'm going to have -6 plus the square root of 48 divided by -6. And I get -0.15. So they're my two x-intercepts. And as you can see here, if I was to graph this function, here's your two x-intercepts, -0.155 and 2.15. Okay, you can also see here's the vertex that we found. And here's the y-intercept. Okay, so it's all there. Okay, so I'm going to come back here and put my x-intercepts as decimals. So 2.15 comma 0 and -0.15 comma 0. So 2.15 is like right about there, and -0.15 is maybe right about here. And then you're just going to make a nice smooth curve, make it look like a U. Okay, not a V. V's are absolute value. And then that would be your parabola. So the domain is easy. The domain for all parabolas is just all real numbers, -infinity to +infinity. There's no holes or gaps or anything like that. The range, on the other hand, would be any values that you can use for y. Well, this graph continues to go on and on and on forever down to -infinity. But it goes up and it stops right here, right? It's not going to go past that point. So that's the point 4. So your range would go from -infinity to 4. And it actually hits 4 because that's the vertex. So that's a closed interval. You're going to put brackets around the 4. Okay, the next thing I want to look at is where is f increasing and where is it decreasing? So remember, when we're dealing with increasing, decreasing, you want to use x values, right? Intervals of increasing and decreasing is always x. So if I look on the left side of the graph, right, that would be from -infinity up to, this is the point 1 comma 4. So I'm going to focus on the 1, right? I'm not using the 4. The 1 is my x. So if I look at the left side of the graph, what's the graph doing? Pretend you're on a roller coaster. It's starting down at the bottom and it's going up to the top to 1, 4, right? So it's increasing from -infinity all the way up to 1. And then you go down the hill. It's decreasing from 1 all the way to +infinity. So remember, +infinity is this way. So that graph is going to continue going down as x approaches +infinity. As you keep moving to the right, it's always going to keep decreasing. It's never going to switch and return to increasing. Okay. In class, you worked on letter A, so I'm not going to do that with you. I will just tell you that the vertex here was -2, -3. The axis of symmetry would just be the x value, so x equals -2. By the way, this is concave up because your A value is positive. Your y-intercept, remember, is the c value, so that would be 5. And then the x-intercepts you're going to get should be something like negative 3.22 and negative 0.78. I am going to do b with you. So first I need to write out my a is 1/2, my b is negative 2, c is 3. So I'm going to first do negative b over 2 times a. So the numerator gives me positive 2, and then 2 times 1/2 is 1. So my x value is just 2. So now I'm going to find f of 2. Okay, so I have to do order of operations, right? Power first, so 2 squared is 4, half of 4 is 2, 2 times 2 is 4, so you have 2 minus 4 plus 3, which gives you 1. So the vertex is 2, 1. And my axis of symmetry is x equals 2. My y-intercept is my c value. Okay, so if I graph what I have so far, I've got 2, 1 is my vertex, and then here is my axis of symmetry. And then I've got my y-intercept, which is 0, 3. And I'm going to reflect that over that line, so it's going to go right here now. And as you can see, just by looking at the graph, there will be no x-intercepts because your vertex is right there. It's above the x-axis. So you're not going to have an x-intercept. So you don't even need to bother finding it or using the discriminant since we graphed it already. And it's going to look just like that. Okay, that's the end of the video for the first part of 4.3. There will be another video for the second part, which is completing the square.